This week on the IoT podcast.
Silicon Labs, we're a semiconductor manufacturer. Over about the last decade or so, we've dedicated ourselves to building products, both hardware and software for the Internet of Things. We talked a little bit about lighting, like metering. That killer use case, in my mind, that drove adoption was billing, or you can not have to roll the truck, as they call it. You could do that automatically. Once you've made it smart, finding all these other services you can do on top of it. And that really takes that return on investment and kind of supercharges it in a lot of these applications.
It then opens up a spider's web of other use cases that come from that. And I think that's the crucial thing that people misunderstand sometimes about IoT, is it is simply the plumbing to enable other services and other benefits to come from it.
IoT is a term that's become so broad, it's almost meaningless. I mean, you could say anything is IoT. When I think about it, where we focus is really on these smart connected edge devices. And there's a lot of unique challenges when you look at those devices.
The killer use case, as the phrase you used earlier, but actually, what can you unlock from doing it? Can I make money from it, and will someone want it?
Welcome back to the IoT podcast. I'm your host, Tom White. Every week, we are joined by the biggest names in IoT to unravel the trends, misconceptions, and predictions for the Internet of Things. Before we get into today's episode, don't forget to subscribe on whichever platform you're watching or listening on, and turn on that notification bell so you're never out of the loop.
Imagine a world where your city adjusts traffic lights based on real-time flow. Your office building automatically optimizes energy use, and utilities detect leaks before they even become a disaster. And all of this is becoming possible now. Today on the show, I'm joined by Ross Sabolcik, Senior Vice President of Industrial and Commercial Internet of Things at Silicon Labs. We're going to explore the expanding universe of industrial IoT beyond just factory automation. Let's get into it.
Welcome back to the IoT podcast show. It's been such a long time actually since I've said that. I've always forgotten where I am and who I am. But thankfully, Ross today is joining me from Silicon Labs. Ross, welcome to the show.
Hey, Tom. Thanks for having me.
And you're very welcome. I've been really looking forward to this actually. So I know quite a little bit about Silicon Labs, or Labs as some people call it, but actually some of our viewers may not know actually what the business is and what it does. So I guess it's a good place to start as ever. Could you explain a little bit about you and the business and what it is you do?
Sure. Happy to, Tom. So Silicon Labs, we're a semiconductor manufacturer. So we design and build products for the Internet of Things. And we've been around since 1999. We were founded here, 1996 actually. We were founded here in Austin, Texas. And over about the last decade or so, we've dedicated ourselves to building products, both hardware and software for the Internet of Things. So that's our primary focus. That's all we really do, is build wireless connectivity solutions for the IoT. The company is split into two halves. There's a consumer-facing business, which we call our home and life business. And then I run our professional and industrial business, which we call industrial and commercial. So it's each business is about half of the company. And we were roughly about $1 billion in revenue last year.
That's absolutely fantastic. Thank you for the overview. I think a lot of people that I know probably already know Silicon Labs and have either worked with Silicon Labs or have heard them through kind of the IoT grapevine. Really good reputation actually in the market. Very good at what you do in terms of the people that you have within the business and the products and services that you create. You touched on it just then, Ross, and this is going to kind of take a flavor for the show that we have today around your particular part around industrial, right? And actually what that means. And this will be really interesting to get into it, because previously when we've had people talk about IoT or Industry 4.0, typically we always focus on factory automation. And of course, that's quite a large part of what it is. And there's many, many use cases. But critically, it's a lot more far-reaching from that. And maybe you can explain a little bit about what we mean by that, Ross.
Sure. Yeah. So what we we have a couple of different major segments that we've rolled up into this industrial and commercial business. And we have a true, what we call industrial business, which is what you would traditionally think of as, the industry 4.0 type initiatives. So factory automation, controlling machines and manufacturing cells. So that's one portion of our business is true industrial. We also have two other segments. One is smart cities, and the other we call commercial and retail. And if you look at all of these segments, they're really focused on large scale problems that are being either confronted by businesses or municipalities that are driving the use cases. So in that smart cities use case, one of the most important applications is around the delivery of utilities. So that could be electricity, water, or gas. And so there's been a major push over the last decade to make those systems become more automated and smart. So, for example, with electric meters, you can do customer billing without someone having to go out and read a mechanical meter. With water meters, you can do things like, again, billing, but also doing leak detection and things like that. And with gas meters, similar type of use cases, but even the ability to shut off the meter if there was some sort of natural disaster. So smart cities encompasses a lot of these utilities, but other applications as well, like street lighting or traffic flow and things like that. Our retail and commercial is also a really exciting segment for me in that we're doing applications that would go into like large retail establishments, commercial buildings and things like that. There's a few big applications there. One of them in particular is electronic shelf labels. So if you think of going to a shop and prices being marked with kind of paper tags on the shelf, the more modern IoT approach is those tags become now smart devices. So you can display pricing, you can update that in real time without someone having to manually go do it. And then you can offer other services on top of that as well. And beyond kind of that electronic shelf label, there are other applications that are driven in that commercial space. So, for example, if you think of lighting, commercial lighting, there's been a big push to transition lighting to be both LED based, but also smart and controllable. So, if you build a lighting system in a building, for example, you can get some energy savings by the fact you move to LED lighting. You could get additional energy savings if you made those lights smart, where you can do building automation to turn the lights off when someone's not in the building, to be able to adjust the brightness depending on what the ambient conditions are, things like that. So those are kind of the three big segments that we break the market up into in this I&C space.
Yeah, that's a fantastic overview. Thank you. I appreciate that. And I think that's really insightful for a lot of our viewers and listeners, actually, because there's so many different use cases around the factory and actually the advancements that can make there. But as you said, there's lots of different areas and lots of different use cases where this is actually quite critical. And we actually sort of joked backstage a little bit about our PIR sensor in my podcast room and why I need to do a big wave to keep the light on at certain points. But actually, we can fix that with IoT, and we can fix that with occupancy sensors and different sensors for different cases. Primarily, one of the things that I see a lot about why this is useful, and maybe you can expand on this a little bit more, is the fact that if you have a sensor, you don't physically need to go to the location in order to check the problem with the individual device or the setting. Is that the main benefit, or, that people tend to use this for? If we look at maybe the utility aspect, and what would be the other benefits where this comes in, Ross?
Yeah, Tom, I think it's a really important question. And when I think about these professional systems, what I've seen in my career is there will be, I'll call it the killer use case or the killer ROI that you would look at with the system. So, for example, we gave that lighting use case earlier of you maybe are installing your lights to make them LED to save energy. You maybe want to be able to control them wirelessly to have, even more energy savings or start to get some of the benefits in terms of, controlling your environment more actively. But what I'll see in all these systems is that that will be the killer use case that kind of gets the system installed. But if you think of lighting, once you build a wireless lighting system that covers an entire building, you now have these sensors or these smart devices over top of this entire space. And what we'll see is customers will then say, hey, I built out this application to control the lights, but are there other services or other insights I can gather by virtue of having that system? So one of the insights could be with a lighting system, for example, hey, which rooms are actually used in my building? So if you have sensors that are saying, turning the lights on when people occupy space, you also know when people are occupying that space. So if you're, for example, managing a commercial building, you could look at it and say, I've got a lot of conference rooms on this floor, but really only about 30% of the conference rooms are utilized. Maybe I repurpose that space, or maybe we look at leasing out that space. So you'll get these other insights once you build the system out. So you talked about sort of sensing. Sensing is an important component of it. There's also a control component that can be there. So as the example you gave with the occupancy sensor or the PIR, the motion sensor, right? You're trying to determine that somebody's in the room and do something, not just say somebody's in the room. So that control component also is important for IoT. But when I look at all those segments, we talked a little bit about lighting, like metering. That killer use case in my mind that drove adoption was billing. So if you think of an old mechanical meter, you had to actually have somebody go out to the premise and read the value of the meter for every meter that you had. So the kind of killer value prop there was, hey, you can not need to do that anymore. You can not have to roll the truck, as they call it. You could do that automatically. But then what utilities started to understand is, wow, I have a smart device that is attached to every home that I'm servicing. What else can I do with that device? So now there's a big push around, for example, doing a monitoring of the grid. So if you're trying to understand, like a portion of the electric grid is being stressed and maybe the voltage is starting to droop, or there's a brownout, or the power has gone out, now you can use these meters as smart sensors and billing devices. So that's another example of kind of taking a killer initial use case, and once you've made it smart, finding all these other services you can do on top of it. And that really takes that return on investment and kind of supercharges it in a lot of these applications.
Yeah, I mean that's so. I'm almost lost for words actually, because I think you're right. but it is. It's also mesmerizing in a way, because you think of one use case as to why this is important, but
Right.
actually it then opens up a spider's web of other use cases that come from that. And I love the example of the occupancy, and was actually saying, well, if I'm the building manager, if I'm the facilities manager, I now know which boardrooms are more in use, which ones are more popular, for
Right.
which reason, right? But it might be closer to the elevator or whatever, actually. And if I was charging for that, then I would charge them appropriately based on use
Right.
and demand, right? So
Exactly.
there's so many different ways that you can then use this, and I think that's the crucial thing that people misunderstand sometimes about IoT. Is it is simply the plumbing to enable other services and other benefits to come from it, such
Right.
as the billing. And that's a fantastic example around the billing. You don't have to roll out the truck. I mean, think about what you've saved in labor from that, and other elements.
Right.
It's really quite special actually, and that's why it certainly does go on much further than just a factory, and almost
Right.
really limitless, I would say, Ross, isn't it?
Yeah, I think that, what we see is, I would make two comments on that. Like another example, think of a circuit breaker, right? Something is what would seem as mundane as a circuit breaker. If you think of let's say an airport, you may have thousands of circuit breakers in an airport, and a light goes out somewhere, and maintenance gets a call that, hey, there's a light out somewhere. You have to go figure out which panel that circuit breaker is in, send somebody to the panel, figure out which of the, numerous circuit breakers there is the right one and reset it. So there's a use case where those circuit breakers are becoming connected. And again, sort of that most in front of your face application is the identifying the circuit that's tripped. But once you make these circuit breakers smart, you can do other things with them. You can look at like what's the total power consumption on that branch of the circuit. Or you can start to even do more like predictive maintenance things. If you're looking at the voltage and current through this breaker and you see something odd, now you can say, hey, there's something strange going on in this circuit. Get an electrician out there before you get a short circuit or something like that. So again, it's that theme of, the IoT is the plumbing. And, part of what we have to do is make that plumbing very easy to install and super reliable. But sort of once you have that, once you have that connectivity, then the use cases are almost limitless. And, identifying the data you can collect and then what sort of insights or business models you want to build on top of that data become incredibly powerful.
Yeah. Yeah, I completely agree. I was just thinking then when you were talking about the circuit and stress testing it, if you use a coalition of different technologies such as digital twin, you might be able to identify it in its twin before it actually went into action, right? So you've got these two elements, both controlling it. But no, I think it's so impressive actually, and I think one of the things that our viewers have commented on in the past actually is where you've kind of got that eye-opening moment where this can be used in so many different contexts and so many different businesses. And I think hopefully what we're trying to do here on the podcast and within this podcast in particular is dispelling that myth to say, well, actually, look, IoT isn't this esoteric kind of niche thing. It's everywhere, but it also can be relevant in your business and your area if you can see the value of it and if you can understand what it can mean beyond just to place a place in the sensor. So I think it's some fantastic examples. And obviously Silicon Labs is doing incredibly well off the back of that, as it stands,
Yeah, I think we identified this as a market we wanted to be in back before it was even called IoT. But our belief was that we will talk a lot about the IoT edge, and IoT is a term that's become so broad it's almost meaningless. I mean, you could say anything is IoT, but when I think about it, and where we focus is really on these smart connected edge devices. And there's a lot of unique challenges when you look at those devices. So as an example, your occupancy sensor you mentioned that we talked about earlier that, can be maddening if it's just based on motion. That may be battery powered because you may have retrofit that sensor into a room. And when you start talking about hundreds or thousands of these devices, you can't be changing batteries every 6 months. You need a really long duration of battery life, or you need to harvest energy from somewhere. So you never have to replace that battery. But, there's different technology challenges when you're talking about these edge devices. You typically don't have a lot of power. You typically don't have a lot of money you can spend. You can't have $1,000 occupancy sensor. So there are all these constraints that really force some challenging technical problems that we have to go solve of how do you make it low power? How do you make it low cost? How do you make it ultra reliable? And how do you fit it into, a form factor that maybe is, the size of a postage stamp or even smaller. So those edge node devices are going to really be the sea of data that's going to get fed into these networks. And, that's really where we live predominantly, or on those edge node devices.
Yeah, I think you've touched on a few things there, Ross, about where this is all going and the impact of this in the future of AI on industrial IoT. But for me, one of the things that I'm always fascinated about is energy harvesting. We've had Simon on from Nowie in the past, Dutch business focused around energy harvesting, and one of the main examples that we've seen previously is, the good old fashioned remote control, for the TV. Actually, you're not needing to change the batteries in that anymore, using kinetic energy to charge it as you throw it around the room,
Right.
But I think that the harvesting element is 100% accurate and on point for me, because it's that's going to be a limitation. The power and powering these devices, because the tech's
Right.
already there, the sensors there, the putting it down into a postage stamp size, as you said. So we need to make sure that all of these things work together in order to get to that point. So is that where you see it kind of going? So obviously at the edge, but do you see the energy harvesting element to this playing a kind of focal point on being able to do this at scale in the future as well?
Yeah, I think yes, and yes, and I would say it depends a lot on the application. So, as an example, energy harvesting, we use a term like if it's dirty, difficult, or dangerous. Energy harvesting becomes really attractive, meaning if it's hard to get to that battery to change it, if it's difficult, if it's in a hostile environment, if there's a lot of them. If you're talking about a remote control, it's an annoyance to change the battery in your remote control. Imagine if you had 1,000 door sensors that were all battery powered in a hotel, and you have to go change batteries on those. That's a whole different scale of problem. So we see a lot of interest in energy harvesting. It's still a continuum, though, between customers who look at the economics and say, hey, the lifetime of my product may only be 7 years. And if I can get a coin cell battery that lasts for 7 years, that product is going to be refreshed when the battery dies. So just makes more economic sense for me to still be very, very energy efficient, but to use an ultra cheap coin cell battery, versus I can't get a long battery life out of a traditional battery. I have a lot of devices. Now let me harvest energy, because there's a cost associated with harvesting in both the element that's going to harvest the energy, storing that energy. So it really depends. It's not a one size fits all, but low power, whether you harvest it or you get it from a battery, is super crucial in all of these applications when you're not tied to a power source.
Yeah, yeah, yeah. It's something I haven't really considered that much. It's what is the pain point
Right.
at that particular area? Because as you say, I think that was a really good point. It's an annoyance actually to change the battery, but it's a whole different quantum, isn't it? When you're talking about 5,000 door locks or something that you feasibly couldn't do.
Right.
So yeah, I think, but the kind of constant with this is it has to be low power. It has
Yes.
to, it has to be, obviously smart. It has to work in the way it's intended to work and be robust. But yeah, that's interesting, and I like the kind of the future of edge on this, and as we touched upon that earlier, and where AI and edge will come with IoT. I think at the moment we just have such a big kind of, I know everyone says this every decade, but I think a big coalition of generative AI both at quantum level and IoT all merging at the same time. It's really an exciting time to be in this field, isn't it, Ross?
Yeah, it really is. And I think if you look at it, I think the large language models have gotten, most of the press, rightly so, around AI. Truly impressive, stuff happening in that part of the space. When we think of the edge, though, there's some really exciting applications there, in my opinion, as well. So, we were talking, going back to the occupancy sensor. Now, typically those are based on a PIR sensor that detects motion. And what's great about them is they're reliable and they're relatively inexpensive. What's difficult about them is we've all had the experience of being in a conference room and you didn't move enough to trigger the sensor and the lights go off. So you have to wave your arms. we're working with companies now that are adding other sensors into that motion sensor to make them be more of an occupancy sensor. So that could be sound, that could be using the radio waves that wireless sensor is using to communicate back to the cloud to actually be almost like a radar to map out the room. And if you start using sound, or even people are using video for mapping, like, are there people in the room? You don't want to necessarily send all that data up to the cloud, wait for it to get processed in an AI running on the cloud, and then come back down and say somebody's in the room. If you can do that on the edge, it'll both be faster to respond, but also you can remove a lot of privacy concerns. So if you think about video, you don't necessarily want to, in every public space, or I certainly don't want to in every room of my house, have a camera that's feeding data to the cloud that, we've all heard of the breaches of that kind of data. I think it's just not comfortable for a lot of consumers to do that. But we've shown with some of the AI acceleration we have in our devices, you could, in one of these low-cost devices, actually process the video at the edge and say, count the number of people that are in a room, and never send that data outside of that device to the cloud. So those edge applications are driving a lot of use cases, either because you need them to have a lower latency, you're concerned about privacy, you need them to happen fast, you might not have the ability to send all that data to the cloud. That's driving a lot of innovation at the edge.
Well, yeah, I think that was a really well explained, actually. I think a lot of people saw, Pete Warden's example a few months back, which he showed about speaking to the smart light and being able to process it, to turning on and off. But actually, that's not the concern. The concern is the sensitivity of the data going to the cloud, the speed at which it goes to the cloud, and whether or not you actually want that going. And you're entirely right and accurate. I'm not going to name any names of some very large businesses. But do you really want that going to the cloud? Do you really want that, in your house, all the time? And I think that's where it becomes terribly personal as well, Ross. Everyone uses the example of saying, would you want it in your house? Right. And I think that's the kind of litmus test to say, I'm good with it or I'm not good with it. So I can totally see the benefit of it. And I'm excited to see where, these kind of edge devices and, advancements in tiny machine learning as well are going. We've had Evgeny Gusev on the podcast in the past from Tiny ML Foundation. And it's really exciting. I think it'll be a really interesting time because, we just seem to be going at a pace of knots at the moment, certainly with all of this.
Yeah, and if you think again about kind of those edge devices, our CTO does a really great presentation where he talks about the resources you have available if you're a small IoT edge device, if you're a cell phone, and if you're a server. If you think of like that continuum from the edge to the cloud, and you look at how much power you can afford, how much processing you have available, and how much bandwidth you have. A occupancy sensor is most likely not going to be a 5 gigahertz Wi-Fi pipe with hundreds of megabits worth of bandwidth. It's probably going to be a really, really kind of small channel you can send data back over. And when you think about those constraints, it really forces you to do these things in a super efficient, intelligent way, because you have all these constraints you can't get around that are just natural there. But if you can find ways to unlock these types of features in that really constrained device, it becomes, transformative in terms of what you can do at the edge.
And I think, do you know what? I think that's the theme for this whole episode for me, is the killer use case, as the phrase you used earlier. But actually, what can you unlock from doing it? Because I think sometimes you really need to think about that. And I think you've articulated this so well throughout this podcast about, what is the benefit beyond the tech to do that? What does it mean? And where can you monetize it from a business aspect?
Yes.
And why would the consumer want it? And I go, and those are the questions. Can I make money from it? And will someone want it? And I think if you can answer that confidently, then I think you've got a winning product, haven't you?
Right. I think the connectivity aspect. So to be clear, I think doing this connectivity well, making it easy for customers to embed it into their products, making it robust and reliable, making sure that we have the features that the customers need. That's really a challenging problem. But our goal is to make it so that when a customer is thinking about adding IoT to their system, they shouldn't be thinking about, well, it's really hard to make the wireless work. They should be thinking about, what data do I want to collect? What business case am I building around that? What's the use case I want to solve? Versus, should this be Bluetooth or Wi-Fi or Thread or Matter? That's our job, is to make sure that whichever technology is right for you, we make sure that it's easy to use, robust, reliable, all of those things. But once you make that decision, I think then once you have that pipe, now it's on the customer to say, this is a use case that I can monetize. This is a use case that's worth collecting data to mine those insights. I'll give you another example. We're in power tools. And if you think of professional power tools, like, why would you put IoT into a power tool? So there are manufacturers that are putting Bluetooth into their device. And like, one of the initial killer use cases was to prevent theft. So you get the tool out of the tool bin in the morning, the foreman comes over with their phone, the tool is inoperable until the foreman unlocks it. So if someone steals it, it's basically worthless as a tool. That was kind of the killer use case. But then when you look on top of that, they've started to do things with the tools like, let's